a slightly more extended amount of time discussing that. The main problems, actually, question one, I think most people were fine with it, which is good because that's the important thing. So just to quickly go over it, everybody, it seems, has understood the rules decently. So okay, so in question one, everything was just using the rules, which, just to remind you, is a to the m times a to the n. The base numbers have to be the same. Is given by a to the sum of the powers. There were some negative powers, so the definition is 1 over a to the n, right? So the minus sign indicates a reciprocal, or it's flipped over. It does not mean that the number is negative, right? So that's a common mistake to make. But just because there's a minus sign in the power does not mean that the number is negative. Okay, so everything was just using those and your fractions kind of knowledge. So the very first one, hopefully you can see that it should be 2 to the power of 7, which is 128. So either way, it's either form is fine. If you wrote 2 to the 7 or 128, it's okay. Next one is pretty similar. The base numbers are all the same, so you can again add as you normally do. So it's minus 3 plus 5 minus 1. So that's 2 minus 1, which is 1. So it's just 5. 4 cubed over 4, hopefully. So I guess there's two ways to do it. You can write out the entire thing if you want, in which case the top becomes 4 times 4 times 4 divided by 4, and you cancel, divide by 4, so you have 4 squared, 16. Or you can convert the bottom into power. So 4 cubed over 4 is the same as 4 cubed times a quarter. And remember how our negative powers are defined. It's 1 over a to the n. So this is 1 over 4 to the 1. So this is the same as 4 cubed times 4 to the minus 1. So this is 3 plus 1, so it's 4 squared again. Okay, next one, 2 to the 7 over 2. So same idea as before. 7 minus 2 is 5. So as long as you're dividing with the same base numbers, it's worth it to know the rule that x to the m over x to the n is equal to x to the m minus n. Okay, so just to recap, I think everybody did fine on this, but just recapping. So yeah, for part E, you can do the numerator and the denominator separately. So at the top you have 3 squared, at the bottom you have 3 cubed. And 3 squared divided by 3 cubed, that's of course 1 over 3. Okay, next one, you have to be careful. The bases are not all the same. So I guess you can look at 2 to the 5 and 2 to the minus 3 first. So that becomes 2 cubed times 3 squared times 2 minus 3. So this is the same. Remember, the order of multiplication does not matter. So it's 2 to the minus 3 times 3 squared. You look at this first. Of course, you have 2 squared times 3 squared. And if you want, you can be fancy and do 2 times 3 squared. This is 6 squared, so it's 36. But 4 times 9 is also okay. Right. Okay, next one, again, similar kind of idea. It's best to join up all the bases that are the same. So 5 and 5, 2 and 2, and 3 is by itself. And doing that, you see that it's supposed to be 5 to the 1, 2 minus 1, times 2 to the 4 minus 2, so 2 squared, times 3 to the minus 1. So this is, of course, 5 times 2 squared times 3 to the minus 1. So you can't do any more. You can't add the powers because the bases are not the same. So it's just 5 times 4 times a third. So this is, 20 times a third, which is 20 over 3. If you want, you can express it as a mixed fraction. So 6 2/3. Okay. Right. Last one. The last two questions were the rules that we learned last class. So it's when you have a power of a power, you multiply the power. So it's 3 times 5 is 15. And when you have power of a product. It's the product of the powers, right? So by that I mean AB to the power of n is the product of the individual powers. So here it's 2 cubed times x cubed. So the answer should be 8x cubed. Okay, so like I said, in general, most people did fine here, so that was encouraging to see. The next one is a bit trickier because the questions were not as standard. So if you found this difficult, don't worry, that was the intention. But everything that the answers here all depend on basically everything, the question one, the skills involved in the question one. So the skills involved are the same, just use it in a different way. Okay, right, so let me ask Satya, what did you get for A?
I think I got it wrong, but
okay, but
the
can you
first
tell me
one
what you got?
one. So for -3 to the power of -2 or something along the lines of 1 over -3 to the power of 2, which is 9. So 1 over 9.
Yes, that's right.
Then it's -1/2.
Yeah, so this is 1 over -2 to the power of 1, which is just, yeah, you're right, -1/2.
And then 1.
Yeah, this is just 1.
And then 0.
Yeah.
1. Then 8.
Yeah.
Then 81.
Okay, right. Yeah, and then what did you do next?
I think I just added them together, but I got it wrong.
I think okay, let's do it. Let's see how you did. So yeah, it's easiest to add the fractions and the whole number separately, right?
Yeah.
So if you add up all these numbers, then you so ignoring the fractions for now, the whole numbers, what do they add up to?
91.
90, so that's 89, 90, 91. Yeah, so, okay. So 91, yeah. Ignore that. Okay, and then so we have to do the fractions. How would you add the fractions?
Oh, could you just have a common denominator? 18.
Yeah, so what does 1 over 9 turn into in the half?
2 over 18 and 9 over -18.
Minus 9 over 18. Yeah. Okay. Yeah, and then?
Oh, just -7 over 18.
Yeah. Okay. Right. So everything we can group together and okay. So -7 over 18. That's our so our final thing is 91 minus 7 over 18. So we just gotta do that. So yeah, it's gonna be a bit tricky, I guess, because the numbers involved are kind of big. But this is right? So if you work this out, it should be the right answer. So if you want, you can save yourself some trouble by separating the 90 into 91 into 90 plus 1, right? So I mean, you don't want to do 91 times 18. So what you do is this is 90 plus 1 minus 7 over 18, right? This one you can do easily. So what is that? The second part. Satya, I'm still asking you.
Sorry,
this part, the fraction.
11?
Yeah,
so what? 11 over 18.
Yeah, right. So it's 18 over 18 minus 7 over 18. So it's 11 over 18. And 11 over 18. So how would you express this answer finally? Would you leave it as that, or would you express it as something else?
Well, you could write it as 90 and then remove the plus.
Right. So this is just a mixed number, right? So this is 90, 11 over 18. Yeah. Okay. Yeah, that's fine. If that's what you did, then you are correct. Now, again, because you're at home, obviously you can't do this in the exam or anything, but all these answers you can definitely check by directly putting it in the calculator, right? So this is for everyone. You can check, that your answer is correct by literally just putting in these numbers one by one in your calculator, or even online and seeing what the answer is. And if you got the same, then you know that you're correct. Okay, so yeah, the answer here was 90, 11 over 18. I think a lot of people made some mistakes with the minus signs. I think that was the main thing. So yeah, you do have to be careful. So my suggestion is that don't skip steps. Do it one by one if you're not sure. So minus 3 to the minus 2 is 1 over minus 3 squared. And then the negative number does not matter for a square, so it's 1 over 9. Right? So you have to be careful. Do it step by step. Okay, so here the answer is given as 1631 over 18, but you can write it as a mixed number also. Okay, part B. Okay, Bebe, can you explain what the difference between these two powers are?
I got it wrong. So
Okay, well, you can still. So what did you say originally? You thought they were the same?
no, I didn't know what the first one was. I just didn't know.
Okay, well, if I put a bracket here, does that make it easier to understand?
Is it? I don't know.
So what is, okay, maybe I should explain. This is 2 to the power of 3, which is, but the 3 is raised to a power of 4.
Oh, that makes more sense.
Right, so if I put a bracket here, what is 3 to the 4? Do you know?
I don't know on the top of my head.
Okay, you can separate it, right? 3 to the power of 4 into two simpler powers.
81.
Yeah, so either you can do 3 squared times 3 squared, which is 9 times 9, or 27 times 3, but that might be harder. So yeah, 81. So 2 to the power of 3 to the power of 4 is 2 to the power of 81. Okay, so compare that with this. Simplifying to this, what does that become? 2 cubed to the power of 4.
2 to the power of 12, sorry.
12, yeah. So which one's bigger?
The first one.
Yeah, and that's way bigger, right? The power is way higher than to the power of 15. Okay, right, so that is the main difference. So yeah, this question was a bit problematic for a lot of people, and I guess it's entirely down to the fact that they hadn't seen something like this before. Not quite. I think I did mention it in class though. So yeah, and you know, it doesn't have to stop here. You can literally go on forever. 4 to the power of 5 to the power of 6 to the power of 7 to the power of 8 to the power of 9, blah blah blah, right? These numbers are going to increase very, 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 very quickly. Okay, right. So again, in general, here the BIDMAS or PEMDAS or whatever you learned in school still holds. I for indices, that's the first thing you do, right? So here the indices is, or the index is 3 to the power of 4, which is to the power of 81. Okay, right. So that's the difference. One is 3 to the power 2 to the power of 81. The other is 2 to the power of 12. Okay, question C. Again, a lot of people struggle with this one. So let me ask Kevin, how did you approach this question, part C?
So I first worked out what 3 to the power of 4 was.
Okay, well, 3 to the power of 4 is 81, right? We just found out.
81. And then you do 90 minus 81.
So 3 to the P is 90 minus 3 to the 4. So it's 90 minus 81, which is 9.
So 3p had to be 2.
Yeah, P is 2 because 3 squared is 9. Okay, yeah.
I'm not really sure how to get R, but I got S instead.
Okay. Let me think. Okay, yeah, what'd you get for S?
For S, I got 4.
Okay, so using the same idea, so what's 5 to the 5?
5 to the 5.
Oh, sorry, 5 cubed, sir.
125.
So you subtract that, this becomes 100 and what is it? 100 and no, I'm sorry, 1296. No, it's 1. Is it? Yeah, it's 1296, right?
Yeah.
Okay, and so this is S is equal to 5. You said
4.
4. Okay, right. So what was the problem with working out R then? Isn't it the same method?
It's just that 4 to the power of 4 is already bigger than 76.
4 squared, yeah, okay, you're right. Maybe actually that was a typo then. I think maybe I did it. Maybe it should have been 4 squared or 4 cubed. Okay, so then it makes sense why people struggle with this, because I wrote the question wrong. So if you were, okay, let's 4 to the power 4 is how much?
256.
Okay, so if you subtract that, does that give you a power of 2? No, it can't because the number is negative. Okay, so it doesn't work. Yeah, so that's my bad. Let's say it's cubed. See if that works. So what is 4 cubed?
64.
Right, so it's, 2 to the r is 76 minus 64, which is 12. That doesn't work either. Yeah, sorry, I think, yeah, that's my bad. Then I messed up there somehow. Okay, so yeah, question C, ignore, I did that wrong. And it turns out r should have been 5. So in that case, 2 to the r is 32, and 76 minus 32 is equal to 34. No, 44. Okay, yeah, something went wrong there. Apologize for that. Okay, so we can ignore C. Part D then. Jing, yeah, what did you say for part D?
I realized that instead of working it out,
Mhm.
you can factorize it into a plus b squared.
Right, so this is a squared, this is of the form a squared 2ab plus b squared, right?
Yeah.
Yeah, like you said, this is exactly this is what I was intending. Of course, you know, if you had the patience to go through this, square all these big numbers, then yeah, you could have done that, but it's easier to realize that this is the case. And what is a plus b equal to?
A plus b equals 1.
Right, okay, and then 1 squared is just 1. So the answer is simply 1. Okay, so I'm glad a lot of people got that, but some people, they actually did the calculation. So, which is fine, you know, it's always good to be able to do the calculation, because a lot of the times math is messy and you have to get through it. But yeah, try to be a bit lazy, but I don't mean, I shouldn't say that really, but sometimes in math, being lazy helps because you can be creatively lazy. Okay, so yeah, here it's just 1 squared, and that is equal to 1. Right, so yeah, the hint here, I mean, I placed it very, you know, obviously, in an obvious way, but a lot of people didn't see it. But hopefully now you can. A squared plus 2ab plus b squared. You're going to be seeing that a lot, so it's good to kind of register that anytime you see it. Okay, this one a bit longer and just more kind of algebra practice. So the difference of two squares formula, we've seen this in class. Hopefully you understand why it's called the difference of two squares, right? It's x squared minus y squared. So it's difference of two squares, two square numbers. Okay, so the first thing was just to multiply it out, the right-hand side. Sichi, can you explain how you multiply out the brackets?
Yeah, it would just be x squared plus yx, take away yx, take away y squared.
Okay, so you're saying it's like x times x, y times x, x times y, and wait, no, okay, I did that wrong. It's minus y times x and minus y times y. Okay, yeah, so basically the idea is you multiply each term with every other term in the other bracket. Okay, something like that. Okay, so x squared minus xy plus yx minus y squared, and yeah, the order of multiplication does not matter here, so the minus cancels out with the plus. So it's x squared minus y squared. Okay, so that was meant to be straightforward. Part 2, a lot of people calculated it straightforwardly. Again, the point was to use the difference of two squares formula. So Livia, how did you do part 2?
It just times them out.
Okay, right. So, okay, that's fine. And if you had to do it using the difference of two squares formula, can you see how to do it maybe? How does the difference of two squares formula apply in this case?
I'm not sure.
Okay, so let me kind of help you out. I'm going to put brackets like this: a plus b plus c and a minus b plus c. Do you agree with that this is the exact same as before?
Yeah.
Yeah, so the minus sign, you have to be careful. Because I put a brackets, the minus sign applies to both b and c. So don't be confused by this plus sign. Okay, now I've rewritten it this way. Can you see what I'm trying to get at?
Yeah.
Okay, so what's the kind of way to do it using the difference of two squares formula? So how does this relate to this, basically? That's what I'm asking.
It's the same as a plus b.
So
and
what
then
is
a minus
x and what is y?
x is a
Yeah.
and y is b plus c.
Okay, right, exactly. Yeah. Okay, and then if you had to use the difference of two squares formula, what would you do? So how would you expand this out using the difference of two squares formula? What does it become?
It is
So using this,
a
so you understand that this is the same as this, right?
yeah, a squared
Yes.
plus minus
Minus. So it's y squared, and you said y is
b plus c.
yeah. So a squared minus
B plus c
b plus c.
squared.
Yeah, exactly. I'm not trying to trick you or anything, right? It's literally what it says. Okay, right. So, I mean, we're nearly done. We've saved a bit of work, right? Because we're not expanding all the terms out, so there's less room for error. Okay, and then, so, Livia, now you need to expand out the second part, right? So a squared minus, what's it going to be? Yeah, so can you expand the b plus c squared?
B squared
Yep.
plus
Okay, so let me write it out if it's easier for you. So b squared plus
2bc
2bc
plus c squared.
Yeah, okay, it's always the same form, right? It's b squared plus 2 of something and plus c squared. Okay, so I put that in, plus 2bc plus c squared, and what do I do with the minus sign in front of the brackets?
It turns into minus
Yeah, so what's my final answer?
a squared minus b squared minus 2bc minus c squared.
Yeah, exactly, right. Okay, thank you. Yeah, so the main point here was to recognize the difference of two squares form. Okay, that was the main thing. The rest is just multiplying out. I know you guys can multiply it out, but the point is to use the newfound knowledge you have to make things easier for yourself. So a plus b plus c, that's this bracket, and the other bracket is a minus b plus c. Okay, and you can rearrange this as x plus y and times x minus y. Y is b plus c. Now, lo and behold, this is the same as before. Okay, right. Next part. Norman, can you explain how to do part 3?
Well, you have to You have to kind of like multiply everything one by one.
Okay, so far the theme has been that you want to avoid that.
Oh.
Okay, so look at these two brackets. Can you see any kind of special things? Are these things you recognize that you've seen before?
Kind of. Not sure.
Okay, let's expand x plus y squared. Okay, what happens if I expand x plus y squared? What do I get?
X squared plus xy plus plus y squared.
So xy plus y squared. Simplify for me.
Equals 2x.
Yeah, so the only thing you can simplify is these two, right?
Yeah.
So what's your final answer?
So x squared plus 2xy plus y squared.
Yeah, okay, now look at this and compare with this. Can you see the similarity?
Yes. Isn't
Okay.
it just like that expanded?
Yeah, so if you had to rewrite the second bracket, a squared plus 2ab plus b squared, how would you rewrite it?
It would be a squared plus b squared, close in brackets and squared.
No, there's no square, it's just a plus b.
A plus b squared.
Okay, now that you've done that, can you guess what this one would be, the first bracket?
Minus
Mhm.
minus a plus b squared.
All right, let's try your idea out. And actually, because it's a square number, the minus sign doesn't matter as long as one of them have it. So I'm going to say a minus b squared. Let's check that this gives us that. Okay. All right. So can you expand this again?
A minus a squared minus 2ab.
Well, so you do a squared times ab.
ab.
Mhm.
Minus ab again.
Yeah.
Then it's plus b minus b.
So it's a minus b times a minus b. What is that?
Plus b.
Plus b or plus b something else?
Plus b squared. I mean.
Right. Yeah. Okay. And so you're exactly right. This is the same as what's down below. Okay. So we're going to use that. So remember, I can rewrite this as what? Norman, I'm still asking you, what can I rewrite that as? The first bracket.
You could rewrite that as a minus a minus b squared.
Yeah. Okay. Right. And remember, they're being multiplied. Okay. Thank you, Norman. Satya, can you see where I'm about to head from here? What am I going to do next?
So would you just times the a, it would be a squared?
You mean like multiply this or what? So I went from the top to the bottom here. Where do I go next?
Was this for E3?
Sorry?
Is this for question EII?
Yeah, E part 3, yeah.
A squared minus b to the power of 4, and then plus ab squared minus ab squared. So it's just
Yeah, okay. No, I mean that's right, but I mean, can you see what I'm going to do next from here? So I've rewritten these brackets as this. Like, what would you do next from here?
oh, you just do it again.
How do you mean do it again?
But instead it's got a plus sign.
Okay. I mean, yeah, there's so there, I have a plus sign, I have a minus sign here. What do I do with these two things?
Times them together.
Yeah, so I want you to tell me how to times them together.
Oh, a times a squared. A times b squared, ab squared. Minus b.
Oh, okay. So
Well,
what you're doing is you're doing like this one, but I'm actually talking about the bottom part here. So pretend you don't know this. How would you
Okay.
multiply these two out?
So for the first bit, it would be a squared minus b squared.
Okay. What do you mean? How's it a squared minus b squared? Because a minus b is a minus b times a minus b.
I'm not sure.
It's not a squared minus b squared, right? It's a minus 2ab plus b squared. Right? So that's not the same. Okay, Suchi, can you see what I'm going to do next?
No.
Okay, what about xy to the power of m? What is this equal to? Right, so x, y, something and something, right? Suchi, I'm still asking you.
Oh, sorry. X to the power of m times y to the power of m.
Okay, do you see how this is related to here?
So a to the power of 2 take away b to the power of 2.
No. No, it's like, so you see this is x and this is y. Right, so this is x, this is y, so it's x squared times y squared. This is the same as xy squared, right? Okay, so yeah, maybe that's a bit too much. Okay, so we're gonna skip that for now. We might come back to it later. Okay, but as long as you can multiply it out the normal way, that's fine also. I just wanted to kind of give you some an alternative way of thinking about it. But okay, so maybe that's a bit too much for now. All right, question 3. Again, a lot of people had some good effort here. It was tricky, and the answer was 13 men. And the best way to see that is, I think, just write it out. Probably that's the easiest way. So we don't know how many girls there are, and we don't know how many boys or women and men there are. So let's say it says Mary danced with 7 partners. So we can literally just like couple them together. So Mary, which is the first girl, danced with 7 people or men. Olga, who's the second girl, danced with 8 men. Vera, which is the third girl or woman, danced with the 9. So you can see how it's going. It's going up by 1. And keep in mind, our constraint is that the total number of people must be 20. So right now, the total is just 8. This is the second girl, which is, so this total is 10. Next girl, total is 12. So you see it's going up in 2. So if you do this, you'll find that the number of girls should be 7, right? That way it'll give, let me write it out. That way it'll give, so 1, 2, 3, I'm just going to write it out. 4, 10, 5, 11, 6, 12, and 7, 13. So you see the total here is 14. Here's 16. Here the total is 18. And here finally the total is 20. So it should be 7 girls and 13 men. Okay. So that was probably the easiest way to see it. I think someone had a really large value for the number of men, like over 20, right? You can't have, if you have a party of 20 people, you can't have, for example, 100 men, right? So you should always check your answer with the question. Okay, so again, quick recap about powers. You've seen this many times now, but it's really important, so I put it there over and over again. Okay, multiplication rule, division rule, you subtract the powers, product rule, AB to the n, all that stuff. Quotient rule, right? Still the same kind of thing, and power of power rule. Okay, so these are all the rules you're going to be using a lot. All right, And also we had the sum and the square of the sum difference, square of the sum and the square of the difference formulae, and also the difference of squares formulae. So a common mistake that people make is a plus b squared is equal to a squared plus b squared, but this is not true. It's actually a squared plus 2ab plus b squared. Okay, there's that middle term that you shouldn't forget. Okay, right, so using the difference of two squares formulae, Livia, can you explain how to multiply 101 to 99?
Brackets 100 plus 1
Yeah,
times brackets 100 minus 1.
yeah, okay, good. And this is equal to?
This equals to
So this is where you use the difference of two squares formula.
100 square
Yeah,
minus 1 square.
yeah, exactly. Now, this is much easier to do than this, right? But these are all the same. Okay, so what's your final answer then? How much is 100 squared?
It is 10,000.
Yeah, 100 times 100, so you're going to have 4 zeros, so 10,000 is right. And then minus 1, so what's your answer?
9,099. 900.
Yeah,
9,999.
4 nines, yeah. Okay, cool. So this is an application of difference of two squares, and again, once you get used to the formula, you can do this in your head, no problem. Okay. Right, so that's exactly what we just said. All right, so here I don't know if we'll have enough time, so I might have to blast through a bit. But so we're going to look at the cube formulae, and the reason we're looking at the cube and later on the power of 4 is that you'll see there's a nice pattern, and I just want to explain to you what it is. So a plus b cubed, again, I'm sure everyone can multiply everything out, but we're going to make things a bit simpler for us, and because we already know how to do this, right? So that's why we're going to save ourselves some work and put that in first before multiplying each one out. So part of the job is already done, right? That's the idea. So a plus b cubed is a plus b squared times a plus b. And I know what a plus b squared is. Again, it's not a squared plus b squared, it's a squared plus 2ab plus b squared. You have to keep that in mind. Okay, and again, when you expand out, you have to expand every term with every other in the other bracket. So that times that, this times this, and b squared times a, and b squared times b, right? So in total, you have 6 terms that you multiply everything out. Okay, if you do that, then what you get is something like that, right? So 6 terms. I'm going to skip over the algebra because that's just not really important right now. Okay, so once you add everything up, that's what you get. Very nice. A cubed plus 3a squared plus b plus 3ab squared plus b cubed. Okay, so I want you to try and find some patterns here, see if you can see them. A cubed, a squared b, a b squared plus b cubed. Okay, so quick question. Given that a plus b cubed is that, how would you work out a minus b cubed? Bebe, do you have any thoughts? Can you see a quick way to do it rather than expanding everything out again?
Would it just be, for the middle part, would it just be minus instead of plus?
By middle part, which one do you mean?
The 3a squared b and the 3ab squared, I think.
Okay, can you explain why those would be negative?
Well, because it's a minus b instead of a plus b, so it's negative, but the last one's plus b to the power of 3 is not negative because minus b times minus b is positive. I think I'm not really sure.
No, okay, you're thinking on the right lines, but be careful with your b cubed. You said it's a cube, so should it? Sorry.
Yeah. I think that should be minus as well, actually.
So this is negative. Is this negative?
I think so.
Use your same idea, b squared.
Oh, then it's positive, I think.
Yeah, okay, and this is negative, right? Because its power is 1.
Yeah.
Okay, yeah, absolutely. Okay, right. So what Bebe is describing is basically you don't need to do all the work again because most of the work is already done. The only difference between this and that is the b becomes a minus b. Now, if this is equal to that, then of course I can do the same. So I turn the b into a minus b. I can turn the b into a minus b here also, right? So minus b, we can do the minus b. Okay, now if I turn the b into a minus b, a cubed stays the same, of course, because a is a. Here, because of the minus b, this becomes minus 3a squared b. Here, because of the minus b, remember minus b squared is still b squared, so that's unchanged. And lastly, b cubed, that becomes minus b cubed. Okay, right. So again, we save ourselves a lot of trouble by just using the previous formula. Okay, so again, and I made a typo there. It should be b cubed, not b3. Okay, right. So we've expanded 3 of them out. So what do you think would happen in the next? Right, that's what we want to talk about. Right. So we have a plus b to the 1. That's just a plus b. A plus b squared is a squared plus 2ab plus b squared. A plus b cubed is a cubed plus 3a squared b, 3ab squared plus b cubed. Okay, so first thing I want you guys to do is actually appreciate the structure of this kind of expansion, right? The form is very symmetric, right? If you have a squared, you also have b squared. If you have a cubed, you also have b cubed. If you have a squared b, you also have a b squared, right? So a and b are treated very symmetrically, right? This is a very democratic process, right? Each is treated equally, right? So then you can guess that a plus b to the 4, it must have some terms that kind of resemble that, right? So Chris, if I asked you, what kind of terms would a plus b to the 4 have? I'm not asking about the numbers in front of the terms, but what kind of terms would you expect for a plus b to the 4?
So you would have firstly a to the power of 4, I don't know what I'm saying.
Yeah.
And then you would have b to the power of 4, obviously.
Yeah.
And then I'm guessing you would have, it's either, yeah, so it'd be a cubed b and a b cubed.
A b cubed, yeah, symmetric, yeah.
And then, yeah, that should be it.
Okay. Yeah, so you've gotten, there's one more, but yeah, you've gotten all of them, all the other ones. So if you notice, the powers always add up to the same. So this is just a way of thinking. Of course, don't add the powers in when you're doing the calculation, but you see there's always 2 of the a and b, right? There's 2 a's here. There's 1 a, 1 b. There's 2 b's. There's 3 a's
And there should also be an a squared b squared then, I guess.
Right, exactly, yeah.
Okay.
Okay, right. So the thought process behind this is that whatever the power is, that's how many of those terms you are multiplying. Okay, when you have a cubed, you're multiplying 3 of either a or b. So you have a cubed, you have 2a and 1b, you have 1a and 2b, and 3 b's. So for power of 4, we expect 4 a's, 4 b's, or 3a and 1b, 1a and 3b because it's symmetric, it must be, and 2a and 2b. Right, those are the terms we expect. So yeah, we expect to have 5. Yeah, Alex?
Another way to remember it would be, depending on the power, going positive numbers, like a plus b to the power of 1, there would be 1 addition sign. A plus b to the power of 2 would be 2 addition signs, and so on and so forth.
Yeah. Yep, that's absolutely correct. Yep. Okay, yeah. So if we have 5 terms, we have 5 minus 1 plus signs. Yeah, that's right. Okay, so and the first term will of course be a cubed, right? Because look at the pattern, right? It goes a squared, a cubed, and blah blah blah. And just a note that I know I always write a first, but there's of course nothing wrong with me starting with b cubed, right? That's also completely fine. It's just I'm following the alphabet, and in the alphabet you start with a. Okay, right. And the next term, it's a bit hard to see, like we described, the number anyway, but so we're going to press on and, oh, no, that's the wrong one. We're going to press on and see, oh, I put that twice for some reason. So yeah, we explained that the powers of a and b will be a to the 4, a cubed b, b cubed, a cubed b, a b cubed plus b to the 4 and a squared b squared, right? This is the terms we expect. Now the challenge is what coefficients will they have? By coefficient I mean the number in front of the letter, right? So if you have 2x, the coefficient of x is 2. If I have 3a squared b, the coefficient of a squared b is 3. Okay, and if I have kx, also here the coefficient of x is k. Right, so it's the number in front of the letter we're interested in, and k is a number in that case. Okay, so we expect that a plus b to the 4 uses these kinds of things. So you can see the pattern. The power of a is going down. Remember, a to the 0 is 1, and the power of b is going up. Right, b to the 0, b to the 1, and b squared. Right, that's the pattern. A cubed goes to a squared, goes to a to the power 1, goes to a to the 0. B to the 0 goes to b to the 1, b to the 1 goes to b squared, and b cubed. Right? So there is a definite pattern here. And our goal today is to work out what that pattern is. So using that kind of pattern thing, we kind of expect these 5 terms for a plus b to the 4. So let's look at the coefficients then. So I've highlighted the coefficients in red just to make it stand out. So a plus b to the 1, yeah, you know all this. And keep in mind, right, if you're surprised by the 1, there's no surprise. A is 1a. We just don't write the 1 when we're doing algebra, right? But if it's 2a, then of course we write 2a. Okay. So yeah, since we're only focusing on the coefficients, right, the numbers in front of the letters, we're just going to write the numbers out without the letters. So so far, this is the pattern: 1, 1, 1, 2, 1, 1, 3, 3, 1. The question is, what's the next one, right? So a plus b, we know that it will be a to the 4 and one of them, and we know it will be b to the 4 and one of them, right? The question is, what's going to happen in between? Jing Yao?
Will it be 1, 4, 6, 4, 1?
Okay, why do you say that?
Because don't we go off the Pascal's triangle?
Okay, well, the idea is that you don't know Pascal's triangle, and we're trying to work that out. Yeah, but okay, sure. If you know that, that's fine. But we're gonna talk about it. So, Alex, yeah.
Would the pattern be every 4? Would it be 1, 4, 1, 4, 1?
Not quite. No. So it's what?
Or would it,
Yeah. So how did you get that pattern? 1, 4, 1, 4.
because I was thinking you have to have 2 on the side. When there's 5 digits, you can have 1 on the side, 1 on the side, and then 4 and 4 on the other side, and then in the middle there'll just be 1.
Okay, so it's a good guess. So in order to verify that, we have to just multiply it out, right? So the first coefficients will be 1, and the second one seems like it should be 4, right? Because it's going 1, 2, 3, 4, right?
Or would it be 1, 4, 4, 4, 1?
Okay, we're going to see what it will be, okay, by multiplying it out. Right. So far we know this. That's what we expect so far. Okay. Now we can guess 2 more again because it must be symmetric, right? Like I said. So it's 1, 2, 1, 1, 3, 3, 1, 1, 4, 4, 1. Okay. So the question is, what's in the middle? So that's the coefficient for a squared, b squared. Remember how it goes, right? I've skipped the coefficient, sorry, the terms, but remember this is for a, this is for b, this is for a squared, this is for b squared, this is for a cubed, this is for b cubed, this is for a to the 4, b to the 4. In between are terms like ab, a squared b, a b squared, and this is for a cubed b, a b cubed, and a squared b squared, right? The powers go down 4, 3, 2, 1, 0, and b 4, 3, 2, 1, 0 for b. Okay, that's what's going on, right? So I've only focused on the numbers, but of course each of the numbers is attached to some algebraic terms. Okay, so in the middle is a squared b squared, because you start with a to the 4, then next is a cubed b, because the power goes down and the power of b goes up. So the power of a goes down, the power of b goes up. Next is a squared b squared, again for the same reason, 3 becomes 2, 1 becomes 2.
So would it be 8? 1, 4, 8.
No. Okay, so now you're just guessing. So how about you wait and then we'll see what it is, yeah? Okay, so right, again, we just brute force it and work it out, right? So that's what you get. So Alex, the answer to your question is actually 6, not 8. Yeah. Okay, so yeah, again, we're trying to work out what the the numbers in front are. So our guess is pretty good, right? The 1 matches the 1, the 1 matches the 1, the 4 matches the 4, the 4 matches the 4, but the only problem is how to get this 6, right? So this is where, again, we could do the same thing with a to the power 5 and see what's going to happen. And I've done the work for you. It's a 5, 10, 1, 5, 10, 10, 5, 1. Right? So this is our table of coefficients so far. All right. So can you see the pattern? Right. So I'll leave that on. I know Jingya already mentioned the triangle, but maybe it's anybody else. Can they see a pattern with this numbers? How is the next one related to the top? And could you guess the next row? So Maria, any thoughts? Can you see any pattern here in this numbers? Okay, Suchi, how about you? Can you see a pattern here?
Well, looking down at the first row, it adds 0 each time, and then down the second row it adds 1.
Yep.
And then the third row it adds 1 more than the previous one.
So you mean like, how do you mean?
Add 2 and then add 3 and then add 4. So the
Okay,
next one
good.
would add 5.
So 15.
And then plus 3 and then plus, would it be doubling every time? Doubling the added number?
Okay. Not quite. So actually, so you mean, so this is 3, this is 6. So you mean this would be 12?
Or 9, I'm not sure which one.
Okay, right. Actually, in this case, it's 10. But okay, that's a good guess. Alex?
I was going to say a flaw with that pattern, because if it started at 0, then it would have to go 1, then it would have to go 2, and then it would have to go...
So she was just looking at the individual columns, right?
Oh, okay, yeah.
Not necessarily column by column. But okay, so that's a good guess. So yeah, it is a bit hard, and I'm going to save you some trouble here. The best way to see it is actually write it as a triangle, like we mentioned earlier. So we write the triangle, the number of coefficients in a more symmetric way. It's kind of like a triangle. So you see it starts 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, blah, blah, blah. Okay, right. So the pattern is that each number is the sum of the 2 numbers on the left and the right hand side of the previous row. So 10 is 4 plus 6, 10 is 4 plus 6, 6 is 3 plus 3, 3 is 1 plus 2, 2 is 1 plus 1. Okay, so that's how this triangle works. All you need to do is start with 1 and then pretend there's a 0 So 1 plus 0 is 1, 1 plus 0 is 1. And the ones always surround everything, so you can always put a 1 and 1 at these sides and just keep adding, right? So now the next one in the middle here will be 1 plus 1 will be 2. The next one in the middle here will be 1 plus 2 is 3, 2 plus 1 is 3. Next one will be 4, 6, 4. Right? So hopefully everyone can see that, right? If you want to work out the next number, just add the top 2 in the previous row. Okay. So Norman, can you tell me what the next row will be for n equals 6? So remember, there'll be 1 and 1 at the end. What's going in the middle?
Yeah, everyone will be 6.
6.
Then it'll be
So you add these two, right?
15.
Yep. Next.
Then we add 15 again.
Nope. 10 and
No,
10.
20.
Yep. Next.
6. No,
Where's
16. Not 15.
15? Yep.
Then 6.
Yep. Okay.
Then 1.
Yep. All right. Okay. So yeah, that's how you do that. All right. And last question, what should be at the top? Well, it should be just 1, because for n equals 0, you just have, remember this at these ends, I should have mentioned, are the powers in a plus b to the n, right? And remember, for anything to the power of 0 is just 1. So that's why we have a 1 at the top. Okay. Right. So that's your triangle, Pascal's triangle. And yeah, we just discussed this. It should be 1, 6, 15, 20, 15, 6, 1, right? And again, remember, here we're only looking at the numbers, but they are attached to some algebraic terms like this, 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 this. So the whole point of this is to make you see that instead of, if you want to do a plus b to the power of 10, which you might, I don't know, one day, then instead of multiplying everything out 10 times, all you do is start at a to the 10, 8, 9, b, a8, b squared, a7, b cubed. You see how the powers are going down, b to the 4, and the power of b is going up, blah, blah, blah. Instead of multiplying it out, you just write the Pascal's triangle and then figure it out instead of multiplying everything out. That's much simpler. Okay, and similar way for a minus b to the 4, you just look at the 4th row, or n equals 4. So it's 1, 4, 6, 4, 1. You just have to be careful about the minus sign. So this might be for homework. Alex?
Wouldn't the top one be 0?
No, because as I explained, a plus b to the power of, remember the n stands for the power, yeah? So a plus b to the power of 0 is not 0, it's 1. Okay, right. So anyway, if we are following the rules that we add the previous two, if we had a 0 at the top, it would not add up to 1. Okay, right. So that's the main thing for today. This was just meant to be slightly extracurricular, right? Don't worry too much about it. It's not, there's not something you'd see in your GCSE. It's just meant to be practice for your algebra skills. So I will focus a bit on this for homework. And just one thing I should mention. So for homework, you should hand it in at the latest by Friday evening, yeah, because then we have Saturday to mark everything and then discuss it on Sunday. Okay, so hand it in by the end of Friday, not on Saturday. Okay, please try your best to do that. Okay, so thank you everyone, and I'll see you guys maybe either next lesson or next week. Okay, bye.
Bye.